So here we have an example that we can use to demonstrate the idea of consensus theorem, and it says that a student may register for course X only if he satisfies the following conditions. The conditions are stated as follows: that condition 1, he should have completed at least 20 courses, is an engineering student, and is of good conduct. And the variables are defined as follows: that condition 1 of having completed at least 20 courses is defined by variable A. Variable 2, that a student is a good engineering student, is given variable B. A good conduct given variable C, with departmental approval D, and the solution is expressed as a function Y. So we can then express these conditions, which are expressed in add operation, as follows. This is A, because has completed at least 20 courses. B is an engineering student, and C is of good conduct. The second condition may be, therefore this may be expressed as A and B and C, because this is an add operation. And the others are similarly following the same: A, B, and D. The last one, this one is the one we are filling in, has departmental approval is D. That is the one. And the third condition is for having 20 courses, engineering student, and should not observe that this is not a good conduct. And oh yeah, this one is also not meeting the condition, which is fewer than 20 courses, therefore becomes A bar. A is when they have met at least 20 courses. When it is not met, that condition is not met, becomes A bar. B is met in the second case, and C is not met. That is why we have A or C bar. So the other one, A, we can express it as CD, because it's good conduct and departmental approval. And the last one is expressed as BD bar, because this is not having departmental approval. So the final expression may be written as Y is equals to A, B, C, or A bar B, C, or B, D, D bar. This is the problem we want to solve using basic Boolean algebra. And in particular, we note that we are going to apply the consensus theorem. So the first thing we observe is that the consensus theorem may be applied in both forms: the reduced form, or the form that is having the redundant term. So for instance, we observe these two. These appear to be in the reduced form, and therefore we can express CD or BD bar. We observe that D is the one that is appearing in two forms. Therefore, we can add the term that may be dropped, which is this term, and this term. You multiply them, you get BC. So we can now introduce BC as a term here, which we have seen that can be dropped or introduced using the redundancy theorem. So with that, we can observe now that this term and this term have a common term, has two common variables, B and C, and therefore if we factor out B and C in A, B, C, we observe that we will have A or 1, which we have already observed that this is equivalent to 1. So these two terms, we may drop this one to be left with only BC. So our new expression for Y becomes ABD or A bar BC bar. So again, we observe that the ABD, these two terms have one term that is existing in two forms, which is D, and therefore we can express it as follows: ABD, and then we produce the product of this term and this term, which becomes AD b, because b dot b is b. Then we write the others, and again once we look at that expression, we observe that this term and this term have one common term, ab, which when we factor out, we will have ab into bracket d or 1, which we say that we can strike this out and we are left with ab. So in this case, we have struck out that out, we are left with ab. So we are left with y being equals to b d bar or a b or c d or b c or a bar b c bar. Again, if we look at these two terms, we want to eliminate the term that is dissimilar to the others. We observe that if we take b as the term that is appearing in one form and ab as a term that is appearing in one form, then we can see that c is appearing in two forms, c and c bar, which means we can introduce another term which is the product of this, and that term becomes a bar b. And once we have done that introduction, this term simply goes, because when you factor it out, c will be odd with 1, and that is equal to 1. So our expression of y becomes b d bar. So when you factor these terms, we notice that we have a common factor b almost everywhere. It is appearing 4 times, and therefore when you factor it out, I will factor it out at this point. So if I factor out b here, I'm going to end up with d bar or a or c or a bar. This term doesn't have b, so this term will come in there, cd. So what we should remember is that a or a bar is equals to 1, and 1 odd with anything else, in this case d bar or c, this will always be equals to 1. So that means that our expression for y becomes b dotted with 1 or cd, and that becomes our final solution. So we have used the consensus theorem or the redundancy theorem to solve the problem that we had involving a student who may register for course X, etc. So that is the solution. Hope it's clear.